Children, welcome to Refresh Concepts. Now, the next category of sums what we are going to deal with is problems based on speed, distance and time. Children, problems based on speed, distance and time are really interesting problems. They are not difficult, but yes, they have good amount of concept involved in it. Now, before we take our problem, I just want you to make you understand a very simple concept. Say we have a stream flowing. Say we have a stream flowing, and we all are aware that a stream always has some kind of slope. So the water is flowing from top to down. Now we have a boat here. We have a boat here. Boat is going to go down and come back. But natural boat will have its own speed, right? So I'll just say let the speed of the boat be B. Don't you think so, children? Because of the slope, nature of the slope, there will be some speed of water also, right? So let the speed of water be designated by W. Even water is running from top to down, so water will also have its own speed. Now when the boat goes from top to down, we say it's a downstream. And when the boat sails from down to top, that is from down to up, we say it's an upstream. Up to down, it's a downstream. Down to up, it's an upstream. Now children, I think so it's very logic, and I hope you will understand also that whenever the boat has to go from top to bottom, that is during the downstream, the water current or the speed of water is going to assist boat also. So what will be the net speed? The net speed while downstream, the net speed will be the boat speed plus the river current or water speed. So during the downstream, my net speed is going to be speed of boat plus speed of water. Speed of boat plus speed of water. Likewise, if the boat is over here and now the boat wants to sail from down to top, don't you think so that we can change? Asha, are we in a position to change the slope of the water, or rather the slope in which the water is running? No, we cannot do so. So water is running from top to bottom, but this time it is our boat which wants to go from bottom to top. So speed of the boat is the same, say B, and speed of water is W. During upstream, it is this speed of water is going to oppose my boat moving in the upward direction. So what will be the net speed? The boat has to overcome the speed of water and travel in the upward direction. So my net speed of the boat will be B minus W. Boat has to overcome the resistance offered or the speed of the water and then move in the upward direction. While moving down, it is the same water speed or river current was assisting my boat to move in the downward direction. But while in the upstream, it is the same water current or the speed of the water is opposing my speed of boat. So we understand one simple logic. During downstream, the net speed is speed of boat plus water, that is speed of river current or speed of water. During upstream, it is speed of boat minus speed of water or river current. Now I want you people to look at what the question says. My question is, Rohan takes 8 hours to travel 36 kilometer downstream and back. So the distance traveled by Rohan is 36 kilometer downstream and back. So he is traveling 36 kilometer upstream also. 36 kilometer downstream plus 36 kilometer upstream, and the total time taken by Rohan is 8 hours. Once again, Rohan takes 8 hours to travel 36 kilometer downstream and back. The speed of the boat in still water, so this time they have given us the speed of the boat. The speed of the boat in still water is 12 kilometer per hour. Find the speed of the water current as we were discussing, that water will have its own velocity, own speed. So here we are supposed to find out what is the speed of the water. So we say let, our solution says, let the speed of water current be x kilometer per hour. Let the speed of the water current be x kilometer per hour. They have given us speed of the boat, speed of the boat in still water. That means we are not taking the water current into account. Speed of the boat in still water is 12 kilometer per hour. Now children, after this particular explanation, I want you people to say what are going to be the next two lines. Therefore can I say speed during downstream is going to be boat plus water. Boat is 12 plus x kilometer per hour, and speed during upstream is going to be 12 minus x, boat minus water. Now, what is the common mistake being made from the student's side? When I say 12 plus x, there are many who will say, sir, 12 plus x and x plus 12 is one and the same. So when they say 12 plus x, over here, they write down 12 minus x. But if they say x plus 12, they write down x minus 12. That is wrong, children. That is totally wrong, because the speed of the water current cannot be more than that of boat. So 12 plus x, 12 minus x. But if you take this as 12 plus x and as x plus 12, and then if you say here it is x minus 12, then we are going to go completely wrong. Now, what is the formula we are having? We have a formula as we know that. What do we know, children? Distance is speed into time. Therefore, can I say time is equals to distance upon speed? Distance is speed into time. Can I say time is equals to distance upon speed? Why did I say so? Because our question that the net time required is 8 hours. Can I say now further as therefore time required to go downstream, distance, what is the distance traveled? 36 kilometer. Upon speed, what is the speed of downstream? 12 plus x. This is what I can say, time required, that much hours. On the same lines, time required to go upstream. Same lines, mind you, but this time my distance remains the same. What changes is nothing but speed. I hope, children, you all are understanding it, right? The time required to go downstream, distance upon speed. Distance is 36 kilometer, speed is 12 plus x. Again, the distance remains the same. Time required to go to upstream is, distance is the same, speed changes 12 minus x. What is the total time required, or total time given? Total time given is 8 hours. So can we frame the equation now? As per given condition. What is the condition now, bacha? What we have to write down? It is time for downstream plus time for upstream. If you want, you can just take bracket here. Need not put bracket in the numerator. The total time is 8. The total time is 8 hours, mind you. Can we take 36 common, children? 36 common. 1 upon 12 plus x plus 1 upon 12 minus x is equals to 8. 36 common is what we have taken. The moment we take 36 common, 1 upon 12 plus x plus 1 upon 12 minus x is 8. Now what we are going to do is, we are going to divide by 36. When we divide by 36, divide by 36 on both the sides. What do I get? When I divide by 36, I'm left with, I think so we should solve simultaneously and take LCM also. So when I take LCM, what shall be my answer then? It is 12 plus x plus 12 minus x and 12 plus x, 12 minus x. That's an easy way to make my children understand about LCM. Though many of them might say that, sir, this is not the right way to teach LCM. Right now, I'm not teaching you LCM. My children of class 10 are very much aware about LCM. I'm just making concepts very, very easy. So when we divide by 36, this 36 goes off. And over here, it is going to be 8 by 36. 8 by 36. Is it further deducible? 4 2s are 4 9s are. Plus x minus x gets cancels off. Plus 12 plus 12 plus 24. 12 minus x, 12 plus x. Children, do not try to go for any kind of expansion. A minus b, a plus b. Answer is a square minus b square. A minus b, a plus b. Answer is a square minus b square. A square minus b square is 2 by 9. 24 by 144 minus x square is 2 by 9. Shall we go for cross multiplication, children? Indeed, we should. 24 9s are 216 is equals to 2 into 144 minus x square. 216 is equals to 2 into 144, 288 minus 2x square. Now, what shall we do is, we shall further bring this 2x square and 288 over here, or you will bring 216 here and ask this 2x square minus 2x square to come here. Our answer will be 2x square is equals to 288 minus 216. 2x square is, how much this is, children? 72. X square 72 by 2, or simply you can say divide by 2. X square is 36. Taking square root, x is equals to plus or minus 6, children. That is, x is plus 6 or x is minus 6. But x is equals to minus 6 is not acceptable. Children, why? As speed cannot be negative. As speed cannot be negative. Therefore, x is equals to 6 kilometer per hour. That's what we were supposed to find out. What is the speed of the water current? Our final answer, therefore, the speed of water current is 6 kilometer per hour. The speed of water current is 6 kilometer per hour. I hope, children, you have understood this particular sum. I wanted that before you deal with these kind of sums which involves upstream and downstream, this is what you should always figure out first. Understand this concept. While moving downstream, the velocities or speeds gets added up. While moving upstream, it gets subtracted. Right? So I hope my children have understood how to solve upstream, downstream sums.